Okay, now let's take up the integration of the fourth function, which is 1 over square root of x square minus a square. This is a very standard function. The numerator is always 1. The denominator is variable square minus a constant. Now let's write it as, let I be equal to integral 1 by root of x square minus a square into dx. Now let's make a substitution, put x equals a secant theta. Now this step you have to remember, whenever the given problem has square root of variable square minus constant, put that variable equals a secant theta. See, for this function we put x equals a tan theta. For this function 1 by root of a square minus x square, we put x equals a sin theta. For this function we put x equals a tan theta. This is a secant theta. Now differentiating with respect to theta, we have dx by d theta is equal to a secant theta into tan theta. Dx is there, so take out the value of dx. Dx equals cross multiply a secant theta tan theta into d theta. We have put a secant theta equals x. Therefore, secant theta is equal to x by a. And we also know one formula, that secant square theta minus tan square theta equals 1. So minus tan square theta is equal to 1 minus secant square theta, or tan square theta multiply by minus, this will become minus, this will become plus, secant square theta minus 1. This is a standard trigonometric identity which we already know. Tan square theta equals secant square theta minus 1. Therefore, tan square theta equals secant square theta is x square by a square, because secant theta is x by a. So it is x square by a square minus 1. Or tan square theta equals a square is the LCM. This is x square minus a square. Therefore, the value of tan theta is square root of this expression. Therefore, tan theta is equal to square root of x square minus a square over a, because the square root of a square is a. Now we have the value of secant theta, which is x by a, and we also have tan theta, which is root of x square minus a square by a, and we have put x equals a secant theta, and we have dx is equal to a secant theta tan theta. Now there are 4 quantities which have to be substituted. Now this implies the given integral becomes I equals integral, I have dx there. So for dx, I have to substitute a secant theta tan theta d theta. A secant theta into tan theta into d theta divided by square root of x square minus a square. What is x? X is a secant theta. So x square is a square secant square theta minus, write this a square as it is. Now simplify this further. Numerator is a secant theta tan theta into d theta divided by a square is common factor in the denominator. Both the terms have a square. Take a square common. A square into secant square theta minus 1. Or I equals integral a secant theta into tan theta into d theta divided by square root of a square into secant square theta minus 1. Secant square theta minus 1 is tan square theta. A square tan square theta. Therefore, the next step is I equals integral, right? Numerator as it is, a secant theta into tan theta into d theta divided by square root of a square tan square theta is a tan theta. Now here you see a and a cancel, tan theta and tan theta cancel. I is integral secant theta d theta. What is the integration of secant theta? Integration of secant theta is log of secant x secant theta plus tan theta. Therefore, I equals log of secant theta plus tan theta. Now the process of integration is over because there is no integral sign. So this is the step where we need to add the constant of integration. Let's say C1 be the constant of integration. Now the last step is to substitute for secant theta and tan theta. From the respective values we already have. What is secant theta? X by a. What is tan theta? Root of x square minus a square by a. Those two values have to be substituted. Or I equals log of secant theta is x by a plus tan theta is root of x square minus a square divided by a plus the constant of integration C1. Or I equals logarithm of a is the LCM in the denominator. A divided by a is 1, 1 into x is x, plus a divided by a is 1, 1 into root of x square minus a square is root of x square minus a square itself, plus C1. Now, this expression, this logarithmic expression is of the form logarithm of m divided by n. The numerator can be taken as m, denominator is n. Here we have one formula, logarithm of m by n is logarithm of m minus logarithm of n. So logarithm of numerator minus logarithm of denominator. Therefore, I is equal to logarithm of numerator, which is x plus root of x square minus a square minus logarithm of denominator, which is logarithm of a plus C1. Now here, if you observe, C1 is a constant, which we have assigned it to be a constant. Logarithm of a is also a constant, because a is constant. So log a is also constant. So a constant minus constant should be another constant, which we represent by C. Therefore, I equals log of x plus root of x square minus a square plus C, where C is C1 minus log a, which itself is a constant. Therefore, what is the final integration of the expression dx by root of x square minus a square? The answer is logarithm of, for convenience, I have written it as logarithm of x plus root of x square minus a square. But this is again a modulus quantity. Log of x plus root of modulus of x plus root of x square minus a square plus the constant of the integration C. Even this result of integration has to be memorized, like how we practice for the first three function. We have the fourth function. Remember, integral dx by root of x square minus a square. It's very easy to remember. Just write log with a mod sign x plus root of x square minus x square is already there in the denominator. So just remember log x with a plus sign, add the denominator, you will get the integral.